So before we start, okay, so please don't forget to subscribe, okay, and then hit the notification button for more videos. Right, so let's start. Let's have the second type of variation, which is the inverse variation. When we say inverse class or inverse, okay, so we are dealing with the opposite quantities or opposite directions of the quantities, unlike the direct variation. Right? So what is inverse proportion or inverse variation? For variables x and y and constant k, if xy is equal to k, then y is inversely proportional to x and y is varies inversely as x. So how are we going to know if the situation or the problem is an inverse variation? Because of these two, is inversely proportional to or varies inversely as. So in equation, unlike direct variation, it is y equals kx. This time it is y equals k over x, and still k is the constant of proportionality. Alright, so what is this? If the first quantity increases, the other one decreases. Alright, or the other way around, if the first quantity decreases, the other one increases. That is the relationship. The best example is demand and supply of products. Okay, so if the demand is increasing, the supply is decreasing. And if the demand is increasing, the supply is decreasing. Alright, so that is the relationship. That is the best example that I can give for inverse variation. Example 3.1. If n varies inversely as m and n is equal to 5, when m is equal to 3, find n. So the unknown value here is n, and then we have n and m as our quantities or variables. This is inverse variation because of the statement varies inversely as. So we need to find n when m is equal to 10. So the first thing that we have to do is to write our variation equation, which is n equals k over m. Then the next thing is construct your first variation equation, which is 5 equals k over 3. Then the other one is n, which is unknown, equals k over 10. So first thing is we need to solve for k using the first equation. 5 equals k over 3. Alright, so 5 times 3 is 15. So k is 15. Next, let's solve for n. Using the second equation, n is equal to k over 10. Substitute the value of k, which is 15. N equals 15 over 10. So simplify 15 over 10 is 3 halves or 1.5. So if we're going to analyze the values of n are 5 and 1.5, while the values of n are, are 3 and 10. So as you can see, the values of n are decreasing and the values of n are increasing. So therefore, the relationship between the two quantities is inverse. Let's proceed. The number of minutes for a cubic centimeter of ice to melt varies inversely as the temperature. It takes 18 minutes for a cubic centimeter of ice to melt at 30 degrees Celsius. How long would it take for a cubic centimeter of ice to melt at 24 degrees Celsius? So how are we going to know if this is inverse variation? Because of the statement varies inversely as. Then you need to identify the two quantities. We have the number of minutes, and then we also have the temperature. Okay, so what is unknown? The unknown is how long. It means we are looking for the time, so we have to let t be the time. Alright, now let's construct our variation equation. Alright, so it will be t equals k over the temperature, capital T. They are not the same. Alright, so let's form the first equation. It takes 18 minutes for a cubic centimeter of ice to melt at 30 degrees Celsius. So therefore, this is 18 minutes equals k over 30 degrees centigrade. Then for the second equation, the time is unknown. Time is equal to k over 24 degrees centigrade. So let's now solve for the value of k. Using the first equation, 18 minutes equals k over 30 degree centigrade. Cross multiply, k will be equal to, what is 18 times 3? 30. So 18 times 30 is 540 minutes degrees centigrade. Alright, next, let's solve for the value of t now, or the time. Using the second equation, t equals k over 24 degrees centigrade. Now, substitute the value of k, which is 540 minutes, degree centigrade. And the unit of answer that we will be needing is minutes, right? So, over 24 degrees centigrade. Alright? So, 540 divided by 24, it's 22.5. So, the time is 22 point, I'm sorry for that. So, the time is 22.5 minutes. So, therefore, we can conclude now that it will take 22.5 minutes for a cubic centimeter of ice to melt at 24 degree centigrade. Now, let's have example 3.3. The measure of the central angle and the number of sides of regular polygons are tabulated below. Okay, so we are talking about the central angle. We can represent this as a theta. So for the number of sides, we started from 4 to 12. Then for the central angle, it's 90 degrees to 30 degrees. So as you can see, okay, the relationship between the two, as the number of sides increases, okay, the central or the measurement of the central angle decreases. Alright, so as you can see in the graph, it's a curve. So if you will be plotting all the points, you will be getting this graph. Okay, let's have the following questions. What is the constant of variation? We can solve the constant of variation by actually choosing one of the pairs. Okay, so we will be having 4 for the sides and then 90 degrees for the central angle. First, we will be forming our equation. Theta equals k over the number of sides. Alright, so independent value is the number of sides and then the dependent is the theta or the central angle. Next, substitute. We have 4 and 90 degrees. So 90 degrees for the central angle equals k over 4. Cross multiply, your k will be 360 degrees. Write an equation for theta in terms of n. So it will be now central angle equals k, which is 360 degrees all over n. Then what is the value of theta when n is equal to 36? Alright, so we will just be using central angle is equal to 360 degrees all over n. Then we divide theta, or the central angle is 360 degrees all over 36. So the central angle will be now equal to 10 degrees. So this will be our answer. Next, last example, example 3.4. Boyle's law states that under constant temperature, the volume V of gas varies inversely as the pressure. If a gas has a volume of 106 cubic inches when the pressure is 14.7 psi or pounds per square inch, find the volume when the pressure is 15.3 psi. So the two quantities that we have here are the volume and the pressure. So what is the unknown value? The unknown value is the volume. Alright, so we will be representing volume of V as the value of the volume. Okay, so let's have our variation equation. So our variation equation is the volume varies directly, or rather inversely, as the pressure. V will be equal to K over the pressure. Then the next thing, let's form the first equation. The first equation, the volume is 106 cubic inches is equal to K over 14.7 psi. Then for the second one, we have the volume, which is unknown, equals the pressure, K over the pressure, 15.3 psi. Alright, so let's solve for K. So in solving for K, we will be using the first equation, which is 106 cubic inches equals K over 14.7 psi. Right, so to solve for K, cross multiply, K will be equal to, what is 106 times 14.7? So it is 1558.2, okay? So cubic inches psi. Then the next thing is, using the K, we can now solve for the volume. Using the second equation, V equals K over 15.3 psi. Substitute the values. V equals 1,558.2 cubic inches psi all over, or rather over 15.3 psi. Cancel psi, then divide. So what is 1,558.2 divided by 15.3? So it will be equal to approximately 101.84 cubic inches. So that will be our answer. Just remember, class, if the problem is under inverse variation, you will see the variation statement varies inversely as or inversely proportional to. I do hope that you have learned a lot in this specific session. Okay, so don't forget to hit the subscribe button and the notification button for more videos. This is Teacher Dong, and thank you so much for being here.